So we are Team TODO, and we are doing the Behaviorix video processing server as a project. So the basic summary of the project is this is going to be some website where users can submit videos for processing on specific video processing algorithms. And this entire project was split into two parts, which two different teams are doing. One is us, and the other is STD Pose. And we are doing the back end of this whole system. So what we are kind of expecting to happen is data is going to be put into this database on the very far left there. And what we are doing is we're continuously checking this database to see what videos come in and what algorithms they need to be processed on, and then processing them with the specified algorithms and then submitting them back to the database. So what we've done is we've set up a MongoDB database along with an API to communicate with this database, as well as an AWS server which stores the actual videos. I'll get into this in a little bit. But the MongoDB database stores information about the videos as well as the results, while the AWS server stores the actual video binary. Along with that, we have also built a, not yet. We've also built a processing manager which pings the API for videos, and then given what it receives back, it schedules them with the specific algorithms that it needs to. So before I talk about the process manager, let me go over the database and the API a little bit. So for our database, we kind of have a very basic setup here. What a few fields that we have are ID, just to specify, identify each video. A vid location object, it's basically going to include the bucket as well as the video name of where the video is located on the S3 server. A requests array, this is going to be filled with a list of different algorithms that specific video needs to be run on. A pending array, which is a list of all of the algorithms that video is currently being run on by the processing manager. Then at the very bottom we have a failed object and a results object, which we'll get to in a little. But basically the results object is going to be an object where the keys are going to be the specific algorithm, and then the value is going to be an object of whatever is returned as a result. As for the failed object, the key is going to be the same. It's going to be the algorithm. However, the value is going to be a string of any error that happened while processing that video. As for the API, at this moment, we only have two routes, which are submit and retrieve. And so with retrieve, it's just going to give you every single video where the request array has some video in it is going to be sent back on a retrieve request. So if this had one algorithm and this had no algorithms, this would be the only video that would be sent back in a retrieve request. As for our submit, it is expecting a specific format, and it's not filled out here, but the specific format that it's expecting is a key for authentication, a ID to know which video the results are going to correspond to, a request array specifying all the algorithms that are processed, and then a results object, which is the results for each algorithm. And it's going to, once you send that object to the retrieve path, or the submit path, it's going to send it to the API and upload it to the database. So now we can go a little bit and talk about the process manager. So the process manager does this very basic pipeline right here. It just fetches requests from the API, handles the request, downloads the video, executes all algorithms that need to be executed on the video, and then sends back the results. The entire system, including the API, is asynchronous, and so one way that you can think about this process is more along this tree pattern right here. Whenever a request is fetched, it spawns a branch to handle those requests. For every request, which is going to be a video, it downloads that video. For every algorithm on that video, it executes a specified algorithm. Then it collects these results back together and sends them out as one big results package. And this entire system is asynchronous to each other. So in a sense, you can think that one video might be downloading while another might be executing. As for the execution of the algorithms, those could potentially be concurrent since they're processes which are spawned. So now we're going to go over a quick demo of how this works. So right here, I'm going to fix that typo. Put in a few algorithms just to test it out. So we can say test algo, test algo 2. We can put one algorithm that doesn't exist, bad algo. We can do the same thing for this video right here. Test algorithm, and then bad again. So we have, for this video, we have 3 algorithms which should process, and for this we have 2. These 2 algorithms are legitimate mock algorithms that we have set up, so they're just going to return some generic data to us for testing. Bad algorithm and bad in this case don't exist, so we should get appropriate error messages for them. So the first thing we're going to do is we're going to run the API. Oh, wait. API is running, and we can go ahead and run the manager. So it should have sent the results out. I'm just going to wait a little bit. Oh, it's sending another result out. I think that was the 2 separate videos, but anyway, if we give it a little refresh. We'll see that in the results object, we have an object of one of the keys is test algo, and it has all the results. Test algo 2 has all the results as well. In the failed object, we have bad algo, and in this case, it is saying failed to execute video because the algorithm does not exist. Same thing for this object over here. Bad failed while test algo returned the appropriate results. And just one more error checking that we could potentially show off is if a video doesn't exist. And if I put like an incorrect name in here. You can go ahead and run that again. Really quickly, I'm going to remove it from temp because the algorithm checks if the video is already downloaded before re-downloading it, so this specific test would work. Okay. So in this case, if I add in any algorithms in here, even if they are legitimate, they shouldn't be able to be executed because the video is unable to be downloaded. Exit out of go ahead and run the manager. So we'll see that on this video, it said, I don't know and test algos, they both failed because the video was unable to be downloaded because the download error was not found. And so that's an overall demo of our entire system. A few key features that I forgot to mention in the beginning regarding the API is the API is there to help with any race conditions. It uses atomic updates throughout it, so you can have multiple instances of the API running, multiple instances of the process manager running, and they won't run into any race conditions due to the features we implemented. And so that's there to both stop any data from being overwritten if two results of the same video are submitted at the same time, and also to allow multiple process managers to run while not wasting resources on the same videos. As far as some key features that we think could be implemented in the future would be, currently we have config files for a lot of things. So in this case, specifying paths and error log files, ports to run on. And so one of these config files is, we have several config files for the algorithms to run. So based on, so in this case we have 4 algorithms and 4 different config files for each algorithm. So by adding these config files into this directory, you can add in more algorithms on the fly without having to do anything with the code particularly. But one thing that could be added is that the program continuously checks if any new algorithms have been updated during its execution, because at this moment in time, and which is all that is required currently, all algorithms before execution are gathered and then used during processing. So that was one of the ideas we came up with, which could be used for